Welcome back. We're going to continue looking at the classification of igneous rocks today. So we're going to see that igneous rocks, or the rocks that used to be melted, has a lot to do with how much silica is in it. The thicker the lava, the more silica that's there, the thicker the lava is going to be. The runnier the lava is, the less silica that you have. So if you were to have a type of lava that has lots and lots of silica in it, you'll have one type, okay, that's called granitic lava, okay, lots of quartz in it, lots of silicates in it. If you have a more runny, like an oceanic lava, like that you would see in Hawaii, that's runny and basically doesn't explode, the volcanoes would just ooze their lava, that would be the basaltic. So you have granitic, okay, and its word would be feltic, and then you have basaltic, basalt, which is the material that comes out of a runny volcano, and that is mafic. And so those are your two big categories. Then you have an intermediate to those, so it's just called intermediate. It's more silica than basalt, but not as much as you would have in granite. And then there is also a fourth one that is very rare on Earth, on the surface of the Earth, called ultramafic, which is found mainly in the upper mantle of the Earth. That's why there's not a lot of rocks that make it this far. Okay, so let's look at all these together. Okay, as we look at the different classifications of rocks, they have a lot to do with the amount of silica that is in it. Okay, so if you have lots and lots of silica, okay, you are going to have thicker magma. If you have less and less, you're going to have thinner magma. And so a lot of this has to do with not just the chemicals that are there, whether it's dark or light silica materials, minerals, but also how much silica is in that. So think of it as a thickening agent. The thicker the lava will be when you have lots and lots of silica. And so you're going to see that this first one, granitic, comes from the word granite. So if you know what granite is, there's 2 or 3 different colors there, usually pinks and browns and whites and blacks, different kinds of dark or light-colored silicates with silica in it. That's granite. And granite is going to be the foundations of most of the mountains. So this is your deep rocks. And so the other word for granitic here is felsic. Okay, so felsic would be lots of silica, at least about 70% silica. So granite is coarse because it slowly cools. If you remember that, the coarse means that the grains in the mineral are very, very large because they had lots and lots of time for the mineral to grow inside the rock. So one mineral is growing next door to another mineral, and they had a lot of time. And so as they grew slowly, and they came out of solution slowly. And so you end up with nice big darks and lights. And granite has all kinds of different possibilities, different colors, different pinks and darks and blacks and whites. It's beautiful and very, very strong. Related to granite is rhyolite. So rhyolite is like granite that would have come out of a volcano. So it's the extrusive, but the same amount of stuff, the same amount of silica and the same light silicate materials that has come out. And so you have all kinds of different browns and pinks and grays. And sometimes, since it did come out of a volcano, you'll have holes in it where there were gases or glass or stuff embedded in it because it was volcanic. We've already talked about obsidian being black volcanic glass that did not have any time for its crystals to come out. And so it was essentially like glass is, very random structure, not a specific shape. Pumice also is full of air voids because of the gases that were inside the lava when it came out of the volcano. There's so many air voids in it that water is actually denser than pumice. Pumice will float in water. There's a picture here of pumice stone floating. Okay, so we had granitic or felsic, and it was really thick, high silica content. Basaltic is the opposite. So basalt is what the lava is when it's really runny. So there's not a lot of silica in it. So it's a thinnish lava. So it does contain some dark silicate minerals and calcium, but it doesn't have any quartz in it. And remember, it's the quartz really that's the pure silica. So the more quartz that you have in it, the thicker that the lava is. So if there's no quartz in it, it's going to be real runny. So like the Hawaiian volcanoes are very runny for that reason. They just ooze out of the volcano. They don't explode out of the volcano. They just seep out of the volcano. Okay, so you've got, because of that dark silicate material, the heavy minerals, heavy irons and stuff that's in it, it's going to be more dense than the granite rocks. And because of that, the crust, which is made mostly of granite, floats on top of the basalt layer. So you have the foundation of the oceans as being denser than the foundations of the continents. And a lot of times the continental crust will ride over top of the subducting, we'll see oceanic crust. And when you have the plates that grind together, we'll talk about that later. Now basalt, we've said, was the oozy lava that comes out of like the Pacific Islands, like the Hawaiian island. Anything that's a volcano over the oceans is going to be basalt. And so since basalt is the lava, that basalt is going to be the extrusive igneous rock. Okay, and it's got all kinds of dark, these dark silicates in it: pyroxene, olivine, these dark greens and blacks, and some feldspar. The gabbro is the intrusive equivalent. So this would have been the same as the basalt, very runny, not a lot of silica in it, not a lot of quartz in it, but it stayed in the ground. So gabbro and basalt are made out of the same stuff. Andesite lava is halfway between thick and thin. So it's not like the basaltic lava, which is really runny, and it's not like the granitic lava, which is thick. This is intermediate. Okay, it's a mixture of light and dark colored materials, and a lot of times this is what's happening right at the margins between the oceanic plate and the crust plate. And so it depends. If it is external, then it's going to be andesite. That's lava because it's coming out of the volcano. Diorite is the equivalent that stays in the ground. So that would be your intrusive equivalent to the andesite. There is one more, and that's the ultramafic, and it is mostly the dark colored minerals, and mostly you're going to see this deep under the ground, way below the crust level. And so this would be more of the upper mantle of the earth, and you don't find a lot of ultramafic rocks. They're really rare at the Earth's surface because they would have had to come all the way from the mantle up through a volcano in order to be found. Okay, so let's look at these again. The first one is the felsic, and it's called granitic because granite is an example of a felsic rock. Lots and lots of quartz, very, very thick. Okay, and the coarse-grained rocks are the ones that were intrusive, so it was in the ground and cools very slowly. Okay, so then rhyolite are the fine-grained rocks. So these would have been the ones that made it out of the volcano. Okay, so those are the felsic. The mafic are the runny ones. So these are the ones that are made out of basalt lava. Okay, so the fine grain, the stuff that actually made it out of the volcano, is just called basalt. Okay, that's what it's called, basalt. Then gabbro is the same stuff as basalt, but slowly cooled underground. Okay, so that's your basically two. You have the thick felsic and the thin mafic. Okay, then intermediate is just intermediate. It's halfway between thick and thin, so it has more silica content than the basaltic rocks, but not as much as the granite rocks. Okay, then the ultramafic rocks are rather rare, because these are the ones that would have been very deep in the ground, way below crust level. Periodite, which is an absolutely beautiful, very sharp rock, is the example. Okay, other than that, very uncommon because we never see them at this level.